Today I received a I2C Mini, and you can read more information by going to I2Cdrivers.com. Here's the actual device after you take it out of the little bag, and it is quite small. The one side here has a micro USB connector in it, and then it has this quick connector, which I think is like a JST4 actually. The packaging includes a breakout wire so that this connection comes with this if you need to hook it up. If you have a non-quick connector device, one of the fun things I noticed here is not only have they documented these different pins well, but they actually made it so that these fit up against standard pins here. And so you can actually just push that against pins if you have this header breakout on something, and those are lined up in the same way that these here are documented. We're going to now go to looking at the actual software component of this hardware device. One thing I forgot to mention is they put these down here right on the bottom so that you can actually place this on top of a PCB board if you were to have little solder nubs sticking up out of that, so you can debug a PCB board that you already have things connected to and see what's going on. For the demo that I'm going to show here, I have the I2C Mini connected to just a small temperature sensor here, so that it's an I2C device, the BMP280, and we'll be able to see that show up once we get the software going. Here's the documentation on the I2C Mini. As you can see here, previous generations had an actual screen on them, and the Mini is a new generation, and the main difference is having that quick connector on it and then no screen. It's a little bit cheaper than the others, and honestly I think for what I'm going to do, this is going to be more appropriate. You can find out where to buy it here, see who has it in stock. Here's an example where they're talking about putting it on a PCB for testing a circuit that you've already got put together. So if you plan ahead, you can monitor I2C in the circuit. Here's a reference for just how small it is. And here's a couple of scenarios where the original and this one are now connected. They provided a nice driver document, which you can find under resources. It's a PDF. A lot of this talks about the GUI tool, which I haven't found all that useful, and so I'm going to show you the command line tool, which is down here. There's installation instructions. One thing to note, I'm using Linux, but it's pretty much the same on Mac. The GUI part is up here, deals with Python, and the actual command line one is much simpler. You just have to go to this repo here, clone it, go into the C directory, and then run make and make install, and then you'll get this little command I2CCL, and you can run it and you'll see something like that. And so here we'll see that indeed when I connected this to USB, it gets detected. When I run that with the I option, we do see information that it's there. Then you can run the -D option here, and that shows what address is connected. And so when I had the temperature sensor connected, that's what you'll see there. And then I now have it connected to a different temperature sensor and a display. And this is going to be an example of actually monitoring it, where you can do -C for capture mode. And when we do that, we can actually see every second there's information going back and forth between these two devices and then ESP32 that's driving them. you see the actual bytes being written, and so you can spy on what's going on with a given setup. The other options you have here are you can actually write bytes to it, which I'm not going to show, but this would be useful for being able to write a device driver for an I2C device that you had the spec sheet for, but no actual code, and you needed to do some troubleshooting. And so you can write from it, and then you can also read from it. And so I think this would be an entire separate video that I'm going to show how that actually works with some simple device. Generally, you can just keep compiling code and debugging in that, but this hopefully will provide a simpler way to do that troubleshooting. The capture, of course, can just help you debug what's going on a different device already hooked up.